Good day, class. Now we are going to discuss on what is an X-ray tube. Usually, the X-ray tube is the part of the X-ray imaging system that is not visible to the radiologic technologist because it is housed by the X-ray tube housing. Okay, so what is tube housing? So during the production of X-rays, they are emitted all directions within the tube. So this is called the isotropic emission. So X-rays that pass through the thin window is called the primary beam. And this beam is what constitutes the image. So the housing protects against electric shock and absorb leakage radiation. Also, the housing protects against electric shock and absorbs leakage radiation emitted out from the beam. And leakage radiation is not very good, or it is harmful for both the patient and the radiologic technologist, as it can contribute to unnecessary radiation dose, which is also harmful for the body. So the leakage radiation is a source of unnecessary exposure for the radiologic technologist and the patient. So leakage radiation should be less than 100 millirentgen per hour at 1 meter from the tube, and more than that is called or is hazardous for both patient and the rad tech, and it should be calibrated. So this is a schematic diagram of the X-ray tube. So this part here is the positive. This is where the anode part is. And this is the cathode part, which is the negative part. This is where the heating of the cloud takes place, and it will be bombarded to this anode area here, and the X-ray that passes through this thin window here is what we call the useful X-ray beam, because that will enter the patient and it will become an image. Okay, so let's talk about glass envelope. By the way, here this is what we call glass envelope. This is what protects the leakage radiation from coming out. The entire cathode assembly and all of the anode assembly except the stator are enveloped or enclosed within the glass or metal envelope, commonly called the tube. So the glass is joined to the metal of the cathode assembly at the one end and the anode assembly at the other. So what is the primary function of the glass envelope? The primary function of the envelope is to maintain the vacuum between the cathode and the anode. When we say to maintain the vacuum, para walang makakapasok na air sa X-ray tube, because if air will comes in the X-ray tube, then it will have an effect in the efficiency of the X-ray tube. So there will be less X-rays that will be produced by the X-ray tube. Yeah, the vacuum should be maintained inside the glass envelope. So after construction of the air is removed from the tube until a pressure of less than 10 over -5 millimeter mercury is achieved. So a vacuum pump is used to permanently seal the glass envelope. It is usually made of a heat-resistant chemical resistant glass called Pyrex. I know you are familiar with Pyrex because ito yung ginagamit sa pangluto. Pero itong Pyrex na ito is a specialized Pyrex glass that is used for Xray tube. Because this withstands the enormous amount of heat that is produced during the Xray production, and all air removed from the glass envelope, creating a vacuum. So the vacuum allows an efficient production of X-rays and also extends the life of the tube. Because again, if the air enters the vacuum, it will affect the efficiency of the production of X-rays. So what is the importance of vacuum tube? The removal of the air permits electrons to flow from cathode to anode without encountering the gas atoms of air. So this greatly increases the efficiency of the tube's operation. So again, it is necessary that there is no air that passes in the vacuum tube. It is to maintain the efficiency of the tube's operation, as well as it will make it will have a longer span of, it will make the vacuum tube longer lifespan. So what is an X-ray tube? This is an example of X-ray tube. So this part here is the cathode, this part is the anode. This is a stationary X-ray tube, and this is the rotating X-ray tube. Later we will know what's the difference between the rotating and the stationary vacuum tube. So the purpose of the X-ray tube is to produce an X-ray beam, and X-ray tube is actually the heart of the X-ray imaging system, because without the X-ray tube there will be no production of an X-ray beam, and without it then there will be no image. And this is also sometimes referred to as the diode tube, and it has two electrodes, the cathode and the anode, designed to produce the X-rays. The cathode is a negatively charged, and anode is a positive charge. So there are two types of X-ray tube. So we have what we call the Crookes tube or the cold vacuum tube. So this was the tube that was used by Röntgen when he discovered the X-ray in 1895. Kaya siya tinatawag na cold vacuum tube. It is because it's not at all vacuum. Marami pang nakakapasok na air. Kaya siya cold vacuum tube. And because of it, maraming air na pumapasok sa tube, the X-ray production is not that efficient. And the second one is the Coolidge tube. It is the modern X-ray tube or hot vacuum tube. Kaya siya sinasabing hot vacuum tube. It is because there is an absence of air that enters in the vacuum space of the X-ray tube. which makes it, or which makes the X-ray production efficient. Kasi pag sinasabi natin pag efficient ang X-ray tube, much better ang production ng X-rays. And there will be less X-rays or MAS that you will give, and there will be less exposure to the patient. So, ito na. Crookes tube. This type of X-ray tube was not enclosed in a vacuum, but instead contained into volumes of various gases. So, hindi siya masyadong efficient kasi punong-puno ng gas. Ito yung ginawa ni William Crookes na ginamit naman ni Röntgen during or when he discovered the X-ray in 1895. Coolidge tube is the modern tube. So it was improved by William Coolidge in 1913, and it is mostly widely used until today. So we have two assemblies, the cathode assembly and the anode assembly. This cathode assembly is a negatively charged. It is where the electron charge will take place. Dito manggagaling ang pag-produce ng X-ray. So, cathode is the negative electrode of the X-ray tube. Its function of the cathode is to produce a thermionic cloud, conduct the high voltage to the space between the cathode and the anode. So, this filament serves, itong filament, this is a part of the cathode, which serves as a vital function of the source of electrons in the production of X-rays. So, this functions to provide projectile electrons for acceleration to the positive anode. The filaments are almost coils of tungsten wire, about 1 to 2 cm in length. Filament is made of tungsten, and this is the material of choice because it has a high melting point and it resists vaporization. Ang pinakamataas na melting point is the tungsten. Kaya since ito ang pinakamataas na melting point, matagal siya mag-melt, so ito ang ginagamit na material for filament kasi napakainit ng napakainit yung pag turn on mo ng machine, at pag uminit ang filament talaga is napakainit niyan. And therefore, dapat the material of choice has a high melting point to avoid it to get melted. Kasi pag ginamit mo lang is aluminum, is matutunaw yan. Wala ka ng filament. And also, rhenium and molybdenum are also suitable materials. And this rhenium and molybdenum are properly used in mammography. So, vaporization produces particles that deposit on surfaces inside the tube, which reduces vacuum in the tube. So, the size of the focal spot is determined by the size of the filament coil. So, modern tubes have two filaments. The big or the large filament and the small filament. The large filament produces a larger focal spot, and the smaller filament produces a smaller focal spot. Filament size. The size of the focal spot is determined by the size of the filament coil. So the longer coil of tungsten is the large filament, and the shorter coil is the small filament. The large filament size is used when high X-ray production is needed, like mag-X-ray ka ng vertebra, such as the lumbar, thoracic, kailangan mo ng large filament. Hindi pwedeng small filament. Pag kinakailangan mo naman ng detail, pwede na yan ang mga extremities. Kailangan mo ng detail niyan. At saka chest X-ray. Smaller filament produces a small focal spot when sharper images or better spatial resolution is required. So lower tube currents should be used with small focal spots. Large filaments produces 0.4 to 1.2 millimeter focal spot. So small filament produces 0.1 to 0.5 millimeters. So ganito yon. If ang kailangan mo pag nag-X-ray ka is kailangan mo ng detail, is you have to use a smaller filament if kailangan mo ng detailed and smaller area. Pag kailangan mo naman ng bigger area and not so detailed, so gagamitin mo is large filament. So paano namin malalaman, ma'am? Saan ba namin i-adjust? So you will adjust that in the control console. May nakalagay doon large filament or small filament. And hindi rin pwede every time that you will use the small filament because it can damage the X-ray machine. Baka mag-overheat. Most specifically, the anode assembly. Filament size. Lower tube currents should be used with small focal spot. Focal spot size is selected automatically by selecting larger or smaller MA stations or manually of the focal spot selections. So, what is this thermionic emission? It occurs when a current is applied to the filament. So, when you turn the machine on, may current na magpuproduce sa filament. And in that filament, sobrang mainit na siya and it can produce a cloud. So, yun ang thermionic emission. So, this cloud of electrons is called the space charge and it becomes the source of electrons for producing X-rays. So, how are X-rays produced? X-rays are produced when filament electrons interact with the anode target. So, dito yon. So, dito yung filament. Pag, the filament charge is negative. And the anode charge is positive. Ito filament na to, syempre, pag sobrang mainit na siya, and this is a negative charge, wala siyang mapupuntahan but to attract the anode part. If it attracts to the anode part, now, the X-rays are produced. And, pag lumabas siya dito, sa glass window, now, this is what we call the useful beam. And this will enter the patient to create the image. So, ganyan puproduce ang X-ray. So, from filament, it will be bombarded to the anode, most specifically the target, and lalabas siya isotropically. Pwede siyang lumabas dito, 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 right, left, kahit saan. Pero, ang lalabas dito sa window is the useful beam that will create the image. That will enter the patient and it will create the image. So that is how the X-rays are produced. Focusing cup. So this is the filament. These are the filament. This is the small filament. This is the larger filament. And this is the focusing cup. The focusing cup is also negatively charged. Filament is a negatively charged. So, kasi nga, pag may electricity, magkakaroon dito ng heat. At sa sobrang heat, magkakaroon ng space charge. And it will attract to the anode, thus producing the X-ray. So, this filament is made of nickel and has two shallow depressions which contains the filaments. So, focusing cup serves to focus the space charge to target area on the anode at the time of exposure. So, the cup is negatively charged, thus repelling electrons. Kasi nga, ang filament, both the filaments are negative. And then, the focusing cup naman is also negative. Di ba alam natin, the same charge repel? So, since magre-repel siya, wala siyang ibang pupuntahan, kundi mag-a-attract siya doon sa anode. Kaya nga, the X-ray is produced. So, this causes the electrons to remain in the small cloud, as opposed to being more spread out. Focusing cup results in the electrons being focused to a smaller area on the target. The anode region is where the projectile electrons strike is called the focal spot. So when a sufficient MA is applied or milliampere is applied, the electrons begin to build up into a cloud around the filament, and this is called the space charge. So, tapos na tayo sa cathode assembly. Now, dito tayo sa anode assembly. Dito sa anode assembly, manggagaling ang X-rays na papasok sa patient. That will create the image. And doon naman sa cathode, doon magpuproduce ang electrons papunta sa anode to produce the X-ray. So the positive anode contains the focal spot, which is where the projectile electrons stop. So it is located on the positive side of the Xray tube. Anode type. So we have two different types of anode, the rotating anode and the stationary anode. Usually, ang ginagamit sa stationary anode is yung mga dental and mammography kasi it doesn't need too much heat during the procedure. Etong rotating anode, kaya siya nagro-rotate para ma-expel niya yung heat kasi sa sobrang heat. And yun ang ginagamit sa general X-ray imaging system. So, electric conductor, it conducts the ito yung functions of the anode. First is electrical conductor. It conducts the high voltage from cathode back to the X-ray circuitry. Second is for mechanical support for the target. Kasi walang paglalagyan ang target. Kasi etong target, dito mismo mag-bombard ang electrons from the filament papunta sa target. So, ang anode mismo ang hahawak sa target. And primary thermal conductor or heat dissipator. When the projectile electrons hit the anode, more than 99% of the electron energy is deposited in the anode as heat. And 1% is X-ray. Only about 1% of the projectile electron energy is converted to X-ray. Imagine nyo, 99% ang heat and 1% lang is converted into X-ray photon. So what are the anode materials? Focus spot reach temperatures of around 3,000 degrees Celsius during X-ray exposure. And tungsten rhenium alloys are commonly used anode target which melts at 3,400 degrees Celsius. A specialized anode disc backed by thick layer of molybdenum or graphite under tungsten target to assist in dissipation of heat. So why tungsten is the metal of choice? Oo nga, maraming klaseng metal. Yung gold, metal yan. O bakit tungsten? Because it has a high atomic number. It has an atomic number, kung hindi ako nagkakamali, which is 74. It results in high efficiency X-ray production and high energy X-rays. And it has a high melting point. Matagal siyang matunaw. Because it can stand up under high tube current without bubbling or pitting. And thermal conductivity, an efficient metal for dissipating the heat produced. Anode materials, both molybdenum and graphite are less dense than tungsten, which makes it easier to rotate the anode. Molybdenum also has a high melting point, while graphite-backed anodes can double the heat loading capacities without the increasing wear to the bearings. We also have mammography X-ray tube. It uses molybdenum, which has an atomic number of 42, as the primary target material due to its ability to emit uniform range of lower energy photons. So the lower characteristic energy photons permits a better soft tissue image. So hindi kailangan masyado ang tungsten kasi hindi naman i-emit ng sobrang heat ang procedure ng mammography, unlike the general X-ray procedures. It uses glass envelope made of beryllium because glass used in X-ray tube absorbs too much of the lower energy beam. Rotating anode. It consists of a target, shaft, and rotor. Rotating anodes spread the heat produced when the electrons bombarded a circular track rather than concentrating the energy in a single spot on the anode surface. It rotates at about 3,600 revolutions per minute. So, ganyan kabilis ang pag-ikot ng rotating anode just to dispel the heat. So, why does the anode rotate? So, in order to spread the heat from the projectile electrons over the larger area of the anode rotates. So the anode shaft and rotor are sealed inside the envelope. An electromagnetic induction motor is used to rotate the anode. So current in each stator windings induces a magnetic field that surrounds the rotor. The stator windings are energized so that the induced MF rotates on the axis of the stator. So this magnetic field interacts with the ferromagnetic rotor, causing it to rotate synchronously with the activated stator windings. So when the rod tech pushes the exposure switch, there is a short delay before exposure is made. So this allows the rotor to accelerate to its designated RPM while filament is heated. So only then is the kVp applied to the X-ray tube. So during this time, filament current is increased to provide the correct X-ray tube current. When the two-position exposure switch is used, the switch should be pushed to the final position in one motion. So this minimizes the time that the filament is heated and prolongs the tube life. Target area. So yung sinabi ko kanina, etong target area, dito yung from the filament, it will travel or it will be attracted to the target area. Ang tawag na area in which kung saan na-attract ang electrons galing sa filament is the target area, which is a part of the anode assembly. The portion of the anode where the high voltage electron stream will impact is called by the following names. It can be focal point, focal spot, or focal track. This is the area where photons are created. So since the target is the point where X-ray photons are created, it is this exact point at which all tube to object and image receptor distances are measured. Okay, so let's continue to line focus principle. Basically, it is the principle that states that the actual focal spot is bigger compared to the effective focal spot. This part here is the actual focal spot, and this part here, etong may linya ito, this is the effective focal spot. Okay, dito. So this is the anode target, and this is the actual focal spot. It is where the electrons from the filament is bombarded and is attracted to the focal track or the target. And this is the effective focal spot, which is smaller. So again, the line focus principle is a principle that states that the actual focal spot size is bigger than the effective focal spot size. Why is actual focal spot size bigger? Actual focal spot size is bigger so that there will be more room for the electrons to travel. Kasi pag maliit ang actual focal spot size, magkakaroon ng overheating ng X-ray tube. At bakit maliit ang effective focal spot size? Kaya maliit so that the image is sharper or the resolution is sharper. Line focus principle. The effective target area or effective focal spot size is the area projected onto the patient and the IR. The effective focal spot size is controlled by the size of the actual focal spot, and it is controlled by the length of the filament and the anode target area. As the actual focal spot size increases, the effective focal spot size also increases. So when the target angle is less than 45 degrees, the effective focal spot is smaller than the actual focal spot. So this is accomplished by the line focus principle. So when the target angle is made smaller, effective focal spot size is made smaller. So before the rotating anode was developed, another design was incorporated into X-ray tube targets to allow a larger area for heating while maintaining a small focal spot. So this design is line focus principle. So ito na nga, ito yung sinabi ko kanina. Ito yung actual focus spot size. Mas malaki siya para mas malaki ang madadaanan ng electrons so that hindi magkakaroon ng overheating ang X-ray tube. And this is the effective focus spot size, mas maliit siya para maganda ang resolution. So the surface is angled to spread the heat from the projectile electrons over the target or the larger area. The angle between the anode surface and the X-ray beam is called the anode target. This principle produces sharper images because the effective focal spot is always smaller than the actual focal spot. The most diagnostic radiography target angle is 12 degrees. When the angle is decreased, smaller focal spot can be achieved. So this advantage of extremely small target angle is that it can limit the size of the primary beam at a short SID or source to image distance. Target angles of less than 14 degrees have been shown to produce cut-offs. Okay, now let's move on to anode heel effect. The use of the line focus principle causes a problem that is known as anode heel effect. Because of the geometry of the angled anode, the radiation intensity is greater on the anode or the cathode side. The X-rays produced are absorbed by the anode itself or by the tube housing. So, heel effect. So, kaya siya sinasabing anode heel effect. It is because, wait lang, ayun, eto. During the anode heel effect, mas malaki ang intensity sa cathode area. Why? Kasi, tingnan mo naman, this is the anode side and this is the cathode side. This is the cathode side. Diba? Walang magi-interfere papunta sa image receptor. Sa cathode side naman, is yung mga photons, it will still travel to the target. So, magkakaroon siya ng lesser intensity. So, the anode heel effect happens when the cathode has higher intensity compared to the anode side. Kasi, magta-travel pa siya dito sa heel ng target. So, mas mataas ang intensity ng cathode kasi walang magi-interfere. Diretso siya. Hindi kagaya dito sa anode part, wherein ang X-ray will travel the hill and it could contribute to lesser X-ray intensity. So the anode is recognized as the head end of the table to more fully utilize the Hill effect into the best advantage. So no significant variations will be seen in exposure from side to side. So Hill effect. So anong magiging effect nito? Kasi if we are going to compare the wrist from the forearm, ang nangyayari dito, kasi mas makapal ang forearm, dapat dito nakafocus ang cathode. At syempre, manipis dito sa wrist, dapat dito naka-focus ang anode. Dapat baliktad. So, ito ang nagiging effect ng cathode or Hill effect. There will be differences in densities. So, ang remedy niyan, kung saan mas makapal, dyan ifo-focus ang cathode. So, dapat dito banda ang cathode kasi mas makapal ang side na to kumpara sa wrist. So, that's the remedy. Or you can use compensating filters. Hindi kagaya dito. So, pareho lang ang density. So, dito, tama lang ang pag-focus ng anode and cathode. So, how to compensate density in an anode Hill effect? So, the smaller field size and larger SID reduce the Hill effect. So, placing thicker part on the cathode side and thinner part on the anode side. So, in chest X-ray, the cathode side should be inferior. The lower thorax is thicker than the upper thorax. So, in abdominal imaging, the cathode side should be superior. The upper abdomen is thicker than lower abdomen. Off-focus radiation. It is also termed as extrafocal radiation. So, it is composed of photons that were not produced at the focal spot. It occurs when projectile electrons striking other parts of the anode away from the focal spot. So, all off-focus radiation is of significantly lower energy than the primary beam itself. So, this is caused by off-focus radiation. So, hindi siya klaro, no? It can cause to an unsharp or low resolution. In off-focus radiation, it causes images to appear unsharp. It decreases overall imaging quality by reducing image contrast and exposes the patient's tissue outside the intended imaging area. But this is not the result of scatter from the patient. Most of the off-focus radiation is attenuated by the tube housing and the collimator. We also have what we call the focal spot blooming. It refers to an increase in the focal spot size with the increase in MA caused by electrostatic repulsion. It is important only with very high MA values and lower kilovoltage settings. So, we also have anode warm-up procedure. So, this is designed to bring the anode heat from room temperature to near the range of operation. It also permits the heat from the hot anode to serve as vacuum pump to maintain a strong vacuum inside the envelope. So an X-ray tube costs about the same as the full-size new car. That is why we need to before the procedure, or every morning before the procedure, the anode should be warmed up so that it could extend the life of the X-ray tube, because an X-ray tube costs about the same as the full-size new car. So tube fails because of heat damage either to the bearings or to the anode surface. So excessive heat can cause filament failure, bearing damage, and anode cracks. So failure to follow the procedure will cause the entire anode to crack if the molybdenum absorbs the heat. So how do we perform anode warm-up procedure? So proper warm-up procedure uses at least a 1-second exposure to include many rotations of the anode during the exposure. So it consists of 70 kVp with several low MA long exposures and 2-second exposures. So tube warm-up procedure should be performed whenever the X-ray tube had not been used for several hours. So heat is the primary cause of X-ray tube failure. Heat increases rotor bearing wear and damages the anode surface. So when the tube bearings begin to fail, they emit a grinding noise noticeably every after procedure. So excessive heat results in reduced tube life. So the length of X-ray tube life is under the control of the rad tech by using minimum factors of MA, kVp, and exposure time appropriate for the examination. So ito yung remedy to lessen or to preserve the X-ray tube life by using the minimum factors of MA, kVp, and exposure time, which is appropriate for the examination. So most X-ray tube failure is related to thermal characteristics of the X-ray tube. The most frequent cause of abrupt tube failure is electron arcing from filament. So, to enclosure due to vaporized tungsten. With excessive heating of the filament used by a high MA operation for prolonged periods, more tungsten is vaporized. So the filament wire becomes thinner and breaks, producing an open filament. So the heat must be dissipated for the X-ray tube to continue to function. So this is an example of cracked anode. So if the anode is broken, then first it could diminish the efficiency of the X-ray production, or second, you cannot use the X-ray tube at all and you have to replace it. And as mentioned, mahal ang X-ray tube. So that is why we need to we need measures or precautions to take good care of it. Okay, so this is our topic for today, which is the X-ray tube, and I hope that you learned something from it. And this is one of our coverage for the pre-final period. Okay, thank you.